in this video, we are going to look at what happens when you integrate a function and it returns to a inverse trig function. So previously we've differentiated inverse trig functions, but now what we're going to do is recognizing when a function is going to integrate back to an inverse trig function. Okay, so these formulas are given in the exam, and so we've got the derivative, or sorry, the integral of dx over a squared minus x squared all to the square rooted equals sine to the negative 1 of x over a plus c. And we've got the integral of dx over a squared plus x squared equals 1 over a tan to the negative 1 of x over a plus c. Okay, so if you were to get given a question that looks very much like that, then it's going to be straightforward. However, it's not always going to be the case. Okay, so if we look here, we can hopefully see that if I rewrite this as root 5 squared minus x squared, then you can see that for this sine inverse sine rule, a is root 5, which means when I integrate it, I'm going to get sine to the negative 1 of x over root 5 plus c. And that's all you need to do. However, this one is a little bit more complicated because the x squared is not on its own. So what I can do is rearrange this equation. And what I'm going to do is take out this 3 so that the x squared is on its own. Which means if I take out a 3 from here, I'm going to have 5 over 3 minus x squared. I can then fully take that 3 out, and it's within a square root, so it's going to become 1 over root 3 integral dx over 5 over 3 minus x squared, but then we need to have whatever a squared is, so that's a squared, so a is going to have to be the square root of this, which is root 5 over root 3 squared minus x squared. So hopefully you can see that a equals root 5 over root 3. Now, when I integrate it, I've got the 1 over root 3 times sine to the negative 1 of x over root 5 over root 3 plus c, which I can then rewrite as 1 over root 3 sine to the negative 1 of root 3x over root 5 plus c. So that's how you would rearrange it in order to integrate it to the sine function. Okay, so let's do 2 more for the tan function. So here we've got the integral of dx over 49 plus x squared. So similarly, we can hopefully see that I could rewrite this as dx over 7 squared plus x squared, and then we can hopefully see that a equals 7. We go back here, a squared plus x squared, so it's going to be 1 over a tan to the minus 1 x over a plus c. So it's going to end up being 1 over 7 tan to the negative 1 x over 7 plus c. So let's do another one. Slightly more complicated again because the x squared is not on its own, so let's deal with that. Let's take out a common factor of the 2, which would leave 5 over 2 plus x squared. So then I can fully take that half out. And again, it's going to be root 5 over root 2 squared plus x squared. So we can hopefully see that a equals root 5 over root 2. So the integral will be 1 over 2 times 1 over a times tan to the negative 1 of x over a plus c. So then let's simplify that. That's going to become root 2 over 2 root 5 tan to the negative 1 of root 2x over root 5. plus c. And that is how you can integrate back to a trig function.